and the bottom equation by a different number such that when we add them, two of the letters will, or one of the letters will drop out. For instance, I could multiply this top one by 5, and I'd have a 15 here. And then I'll multiply the bottom one by minus 3, and I'd have a minus 15. When I add them, I would not have an x anymore. So you pick out anything you want to that will make one of the letters disappear. So what I will do in this example is multiply the top one by 1, or really just write it down, and then multiply the bottom one by 2, and here I'd have a plus 2 up here and a minus 2 here. So basically what you can do is you multiply the top one by the bottom coefficient here, and you multiply the bottom equation by the top coefficient. That's how simple it is. All right, now let's look at my notation. What I then will do is multiply the top one by 1. So that's the way I denote it, multiply by 1. So I multiply everything by 1. And then I'm going to multiply the bottom one by 2. So I get 10x minus 2y equals 22. And now I add. Adding, the y's drop out, and I get 13x is equal to 26. Now that's the process. That's how simple the elimination method is. You simply multiply the top equation by the coefficient of the bottom one, and the bottom equation by the coefficient of the top, and then make it where they're opposite signs, and when you add, that letter will drop out. All right, let's continue the problem now. We have now 13x equals 26. And the rule is if I want to move any number from one side of an equation to the other one, I do the opposite operation. These are connected by multiplication, therefore I divide both sides by the same thing. And the 13's drop out here, and I leave x. 26 divided by 13 is equal to 2. So I found x equals 2. How do I find y? Well, what I do is I go back to the equation 1, the original equation, and plug this value in for x. So the original equation was 3x plus 2y equals 4. So I go plug the 2 in for the x. I get 6 plus 2y is equal to 4. Moving the 6 across, it's added, so I subtract it from both sides, and so I get 2y is equal to minus 2. The 2 and the y is connected by multiplication, therefore I divide both sides by 2, and so I get y is equal to minus 1. Well, those are numbers. Well, what does it mean? Well, what that says then is this. The solution set is the point 2 minus 1. The solution set. What that says then, let's look back at the original equation, is if I put a 2 here and a minus 1 here, it will equal to 4. And if I put a 2 here and a minus 1 here, it will equal to 11. That is the only set of values for x and y that will make both these equations true at the same time. So you understand that I could put a 3 here, which would be 15, minus 4 is equal to 11. But if I put a 3 here and a 4 here, it doesn't work. There are a lot of answers for one equation, but for both equations at the same time, our solution 2 minus 1 is the only set of values for x and y that will work. Well, across from this work in your notes, you will see the graph. So let's see what that means graphically. All right, so we would graph the equation 3x plus 2y is equal to 4. Now to graph that, the way I do it is I put my hand over the y and I solve for x. So solving for x would be 4 thirds. So there's, I put my hand over the x, y is 2. And so I get this line. All right, and then if I graph the line 5x minus y is equal to 11, put my hand over the y, and x is 2 1/5. And if I put my hand over the x, then y is a minus 11, that's somewhere down here. And And look what happens. Right here, where they intersect, the point of intersection is that value 2 minus 1. So this solution set right here is the only point on this line that is also on this line. So what we have found is the solution. What we have found is the intersection of the two lines. So I want you to look at your notes and remember these three words. First of all, the word consistent. Consistent means there is an answer. Now, we'll look at an example later that's inconsistent. Inconsistent means that there's no point on one line that's on the other line. They don't intersect. Inconsistent means there's no solution. All right, so we have the word consistent and inconsistent. Consistent means there's an answer. There is a point on one line that's on the other line, at least one point. All right, some textbooks use the word independent and dependent. Okay, independent is the same idea as consistent. All right, so when we have this answer, we have what? One solution, we have consistent, and we have intersecting lines. One solution, consistent, intersecting lines. All right, let's look at the second example. And let's do it. All this example is doing is going to show you an algebra concept. It's really the same type of work, but we're going to talk about it. So here we go. We have these two equations. And what I want to do is get rid of one of the letters. Well, let's see. I can multiply the top one by the bottom coefficient. So I multiply the top by 2 all the way, and then the bottom one by the top coefficient. Now they're both pluses here, so I need to multiply one by minus to make it one to be a plus and one to be a minus. Doesn't make a difference which one. So what I will do is multiply the top equation. Equation 1, multiply it by 2. Now be careful on this. Remembering that you must multiply everything. 2 times this, 2 times this, and 2 times this. A lot of mistakes that all of us make is we forget to multiply this over here. So multiplying the top one by 2. 2 times that's 6x. 2 times that's 4y. 2 times that's 6. Multiplying the bottom equation by a minus 3. I will have a minus 6. A minus 3 times this is a minus 15, and a minus 3 times this is a minus 6. And now I have the same values for x, one being a plus, one being a minus. So when I add these, the x's drop out, and I get a minus 11y is equal to 0. Now please be careful in your work. Quit looking at that and say, oh, I already know the answer, or whatever. How do I move this across the other side? It's connected by multiplication, therefore I divide. Dividing 0 divided by minus 11 is 0. Okay, so y is equal to 0. So what I do, I now take that value of y and go back and plug it in the first equation. So I have 3x plus 2 times y, which is 0, equals 3. Well, 2 times 0 is 0. So what that leaves me is 3x is equal to 3. So now these are connected by multiplication, therefore I get rid of 3 by dividing it. 3 divided by 3 is equal to 1. Therefore, that means my solution set is x equals 1, y equals 0. So x equals 1, y equals 0 is the solution set. That means the lines are consistent. That means they intersect with one solution. Well, let's look at that graphically. Okay, again we have 3x plus 2y is equal to 3. So if I put my hand over y, I get x equals 1. So 1, 0. If I put my hand over the x, then y is 1.5. So y is 1.5, and so I get that line. All right, let's take the second equation. 2x plus 5y is equal to 2. If I put my hand over the y, x is 1 again. Hey, that's the same 1 again. And if I put my hand over the x, y is 2/5. And so I get this line. And look what happens. They intersect at the point 1, 0. So we have one solution, which means intersecting lines, which means consistent. Okay, now let's look at some examples where we get other things to happen. So looking at example 3, the first part of it, we have the equations 3x plus 2y equals 4 and 6x plus 4y equals 8. All right, what do we want to do here? Let's see. I can multiply the top equation by 2 and the bottom one by 1, and I'd have 4 and 4. That'd drop out. So let's see. So let's multiply the top one by minus 2 to make this a minus. So we'll multiply equation 1 by minus 2. So we get a minus 6x, minus 4y, minus 8. Bottom equation by 1, or just copy the equation down, whichever way you want to think of it. And now what happens? When we add here, everything drops out. The letters drop out. If the letters drop out, then you have special cases. Okay? So, here we go. If everything drops out, we now talk about dependent equations. Okay? They're consistent. There are solutions. What happens on this, there are many solutions. So what we have here is, let's look graphically at what we have. If I graph the first one, 3x plus 2y is equal to 4. If I put my hand over the y, x is 1 1/3. If I put my hand over the x, y is 2. So I get that line. And now if I graph 6x plus 4y is equal to 8, if I put my hand over here, x is 4/3. If I put my hand over the x, y is 2. And what I get is the same line, So pay attention on the notes. What happens is, if everything drops out, what we have is many solutions. Instead of one solution, we have many. Every point on one of the lines is on the other line. So we have all these points, all these solutions. So we have many solutions. Still consistent, but we now have the word dependent that textbooks are going to use. Okay. So these equations are dependent, many solutions, same line. Same line. All right, let's look at the other part of example 3, right across in your notes. And what I did here is I changed this to a 5 rather than 8. So again, if I multiply the top one by minus 2 and the bottom one by 1, then these y's would drop out. So multiplying the top by minus 2, I get all this. The bottom by 1, I get this. And now when we add, we get 0 equals to minus, hey, that's not true. We cannot have a number 0 equals to the number minus 3. That doesn't work. So if all the letters drop out over here, but the numbers don't drop out, these are called the constants. If the letters drop out, but the constants don't drop out to be 0, then this is a no solution. A no solution. Okay. Cannot be. That means there's no point on one of the lines on the other. Well, let's see what we get graphically again. So if we graph 3x plus 2y is equal to 4. We've done this several times now, so we ought to be able to know what this one is, all right? So this is the line right here. Now, look what happens if we graph 6x plus 4y is equal to 5. If we put our hand over the y, we get x to 5, 6. That's back to here. If we put our hand over the x, then y is 1 1/4. Look what happens. And what we get is parallel lines. So here are the 3 words. Remember, we want to know whether it has solutions or not have solutions. We want to know whether it's consistent or not consistent, or dependent or independent. And we want to know what happens graphically. So here are the answers. No solution means inconsistent, parallel lines. That's 3 words. No solution, inconsistent, parallel lines. Now we use those 3 to describe either what do we had? Intersecting lines, same line, parallel lines. That's the 3 things that can happen when you have 2 lines. They can either intersect, They can be the same line or they can be parallel lines. Well, parallel lines mean no solution. Same line means many solution, and intersecting lines mean one solution. All right, now that concludes that part of the tape in terms of how do we solve for the answers to two equations, two unknowns by elimination, and we looked at what happens graphically. Now let's do the same problems, all the same problems, by substitution method, another method of solving. Now, in my opinion, substitution method can be a useful tool when you don't have a number in front of the y. Now, I'll work one with number in front of that, but anyway, the elimination method gets the job done very quickly. The substitution method has usefulness for other cases, so we're going to learn about this. All right, so we're going to solve this by substitution. Substitution method says this: take one of the equations, go solve for the letter. Pick out any letter you want to, any equation, and go solve for one letter. So I'm going to take this one because it has a 1 in front. So I'll move the 5x across, so I get a minus y is equal to a minus 5x plus 11. So I will now divide by minus 1, dividing everything by minus 1. I now have y is equal to 5x minus 11. I now substitute that in the first equation where the y is. Remember, our first equation was 3x plus 2y equals 4. I now go substitute whatever y is, I put it where the y is. So we now have 3x plus 2 times 5 is 10x plus 2 times a minus 11 is a minus 22 is equal to 4. Adding my x's, I get 13x. Moving the 22 across by adding it. Remember, we move things across the equal sign by doing the opposite operation. This is connected by subtraction, therefore I will add it. And we're back to the same problem we worked before, and you can finish it out. Now, when you get x equals 2, remember you would go put 2 back in for the x in the first equation, find y, and you would have the solution. All right, let's look at example 2. Same example, 2 again, we're going to work it. So here we have these two equations, and now what I'm going to do is pick an equation. It doesn't make any difference which one. I'm going to pick an equation, solve for the letter. So here I'm going to pick out x. So move the 5y across, so it's a minus 5y plus 2. Then I will divide everything by 2. And I'm going to show you why to do it this way. Don't divide 2 into that and 2 in this one. Just say all of this divided by 2. So therefore, x is minus 5 plus 2, 5y plus 2 over 2. I will replace that for the x in the equation 1. Now, if you get this x from equation 2, go back and substitute it in the other equation. If you get the letter from equation 1, go back and substitute it in equation 2. Don't go back and put it in the equation that you got it from. Okay. So we got this from equation 2. We will go substitute it for x in equation 1. So 3 times this plus this. Okay, so I multiply the removing parentheses here. 3 times this is 15. Oh, I'm sorry, I left off the minus right there. 3 times a minus 5 is a minus 15. 3 times 2 is 6. Then I write this down. Now, what's the rule when working linear equations? One letter is if you have a denominator, you multiply everything through by the denominator. So I'll multiply everything through by 2, multiply this by 2, multiply this by 2. And so we get the rest of the work. Adding the y's, look what happens. We're coming down and getting the same step that we had before. Solving for y is equal to 0. Go back and plug it in. We've already discussed that. All right, let's look at example 3. Now, the example 3 here is where we're getting these special cases. So look what happens, all right? So this time I'm going to take equation 1 and solve for y. Taking equation 1 and solve for y. So move the 3x across. I get 2y is equal to minus 3x plus 4. Then I will divide everything through by 2. So y is equal to minus 3x plus 4 divided by 2. I go plug that in for y in equation 2. Remember now, I solve for y in equation 1, So I go plug that value in for the y in equation 2. So I have 6x plus 4 times all that is equal to 8. Well, right here, this divides into that. So I have 2 times a minus 3x, which is a minus 6x, and 2 times the 4, which is 8. Now look what happens. The 6x and 6x drop out. I subtract 8 from both sides. Everything drops out, and we end up with 0 over 0. Again, here we are. Same place before. 0 over 0 means what? Many solutions, same line, consistent. Has answers, has many answers. All right, and the last example again that we're working with by substitution is you just do the same thing we just got through doing, same work we just got through doing, and what happens down here now is we get 6x minus 6x plus 8 equals 5. Now, these drop out, but when I move the 8 across, I get a minus 3, and look what we have again. We have the no solution. 0 cannot be equal to a minus 3. So when you get all the letters to drop out, but the numbers don't drop out, then you have no solution. Parallel lines. Okay, now this concludes the part on solving two equations, two unknowns by elimination and substitution. The other part of the tape now is I'm going to discuss how to do this by Cramer's rule. All right, let's look at Cramer's rule. Cramer's rule is a shortcut method that's really useful, and it's a good way of solving 2x2s and 3x3s. So let's look at Cramer's rule. We're going back to example 1 again. No worry, here's written in your notes. So we have 3x plus 2y is equal to 4, 5x minus y is equal to 11. Here's what we do. For Cramer's rule, we do this. To solve for x, the denominator will be a determinant made up of the coefficients of the x's and y's. This is the coefficient in front of the x in equation 1. This is the number in front of the x in equation 2. This is the number in front of the y in equation 1. This is the number in front of the y in equation 2. So the denominator will be the x coefficients, y coefficients. Now the numerator is this. If I'm looking for x, I replace the x column with the constant numbers. Remember, 4 and 11. So I take these two numbers, the constants, and put them in place of the x column. If you're looking for y, you would take this 4 and 11 and put it in place of the y column. That's how simple the concept is. So let's say it again. Solving for x or y, the denominator is the determinant of the coefficient of the x's and y's. The numerator is, if I'm looking for x, I replace the x column. I replace the 3 and the 5 up here with the constants, 4 and 11. That's how simple it is, and that's it. Now we work to determine. Now, working to determine, if you don't know how to do this, I'll explain it now. To do a 2x2 determinant, you multiply down. 4 times a minus 1 is a minus 4, and you multiply up. Now, when you multiply up, you change the sign of whatever you get. Multiplying up is multiplying up is 22, but we change that sign to a minus 22. All right, let's work the denominator. Multiplying down is a minus 3. Multiplying up is a plus 10, but we change the sign when you multiply up. So what we get then is a minus 26 divided by minus 13, and that's equal to a plus 2. Same answer we got a while ago in example 1 for the x value. All right, let's do y. Doing the y, all right, what do we have here? We write the denominator down, coefficient x's, coefficient y. We replace the y column with the constants, 4 and 11. So multiplying down, we get 33. Multiplying down here, multiplying up, we get a positive 20. We change the sign to a negative 20. And now why do we do this again? We don't have to. We already solved this. This denominator was a minus 13. when we did the x. So what do we have here? We have 33 minus 20 is 13, divided by minus 13, and so we get a minus 1. So the solution is x is 2, y is a minus 1. See how nice Cramer's rule is? It's really a good, nasty way to get the job done. Trouble with it is it only works with 2 by 2s and 3 by 3s. All right, let's look at example 2. Looking at example 2, we have 3x plus 2y equal 3, 2x plus 5y equal 2, so we're going to solve for x. Okay, then determine top and bottom. Now I do the bottom first, so that would be 3, 2, 2, 5. The numerator now, I do what? I'm looking for x, so I replace the x column with the constants. Well, they happen to be the same thing. 2 and 5. All right, so what do we get here? Multiplying down, we get 15. Multiplying up, we get, change the sign, minus 4. Multiplying down, we get 15 minus 4. So that's equal to 1. Well, that's right. That's what we got a while ago. Now let's do y. Coming up here, let's look at y. Okay. Y, hey, we don't need to fool with this. Y, we have that denominator. That denominator was 11, so just write that answer down again. You don't have to write that denominator down a second time. All right, the numerator now. Numerator is 3, 2, and we replace the y with the constants. So what do we get here? We get 6 minus 6 over 11. That's equal to 0 over 11. That's equal to 0. So our solution set is x is equal to 1, y is equal to 0. Very simple, very simple. All right, let's go to example 3 now. Remember, example 3 is this case where we get the no solutions and the mini solution type of situation. So example 3, what would we have here for x? All right, for x here, the denominator would be 3, 2, 6, 4. The numerator would be, for x, we replace it with the constants. We replace this with the 4, 8. We have 2, 4. All right, multiplying out, we get 16 minus 16. Bottom, we get 12 minus 12. Oh, we get 0 over 0. Remember, we can't divide by 0, so we got to worry about that. So let's leave that like it is. And now let's go back and solve for y. Okay, solving for y. Okay, denominator 0. What's the numerator? Numerator is, we write down 3, 6, and replace the y with the 4 and 8. Multiplying down, we get 24 minus 24, so we get 0 over 0. Now, notes, look at your notes, and remember this. If you get all zeros, everything, 0 over 0, 0 over 0 for all the letters. That's got to be for all the letters. If we get 0 over 0, 0 over 0 for all the letters, then this is a mini solution. Now, I want to talk about mini solutions. Okay? Let's look at what we do for a final answer on this. So let's go back, and I have this in the notes, and I forgot about talking about it earlier. So let's go back to this. What do we do if we have many solutions? We're really supposed to write it down as an answer, not just the word many solution. So what we do is take one of the equations, doesn't make a difference which one, take one of the equations and solve for one of the letters. So we'll solve for our y. So that's a minus 3x plus 4. Dividing everything by 2. We get y is equal to minus 3, excuse me, let me rewrite this. Move it down some. We get y is equal to minus 3 halves x plus 2. Now that's one way of writing the solution. That's a mini solution. What that says is if x is 1, I get this answer. Y would be minus a half, or plus a half. If x is 2, y is equal to minus 1. If x is 4, y is equal to minus 4, and so on and so forth. Okay. Some textbooks will write this be a, and minus 3 halves a plus 2. But I wanted to come back and talk about this now. If you have a mini solution, most textbooks or teachers will want you to write the answer as an equation. Okay, now let's look at the last thing that can happen when you're using Cramer's rule, a 2 by 2. And this is that example where we got no solution. So what we would do here, for x, denominator would be 3, 6, 2, 4. Numerator would be 4, 5, 2, 4. Replacing the x column with the constants. Multiplying down, we get 16 minus 10, 12 minus 12, and so we get 6 divided by 0. This is where you get to stop. If you ever get non-zero number divided by 0, then it's a no solution. Right then, you get to stop. Cramer's rule. You don't have to look for the other letter. If you get a non-zero number divided by 0, then this is a no solution. Okay, this concludes the tape on solving systems of equations working with 2 by 2s.